Okay, greetings everybody. How are we all doing? I hope you're all doing well. Welcome back to the second video in the Python Basics series. Today we'll be covering numbers and types of numbers within Python, and also the basic arithmetic that you can do on these numbers within Python. So firstly, I want to cover integers. Now, integers you can look at as basically solid numbers. They mean the exact same thing that they mean in real world mathematics. An integer is a number like 1 or like 20 or even 200. It's a number without a decimal point behind it. Now, within Python, the way you note down an integer is like this. Now this 10 was already an integer before we put the int and the brackets around it to assign it to be an integer, but you can do this to decimals to make them integers. I'll show you how that works using a print statement again so we can see what we've done in the terminal. So say if we put 9.99 and we gave it an integer data type instead of its natural, what is called a float, which we'll cover next, but we'll just say a decimal because we all know what decimals are and we can keep it to that base value for now. So if we run this, we'll see what happens. We get a 9. So Python just kind of, it doesn't really round up. Naturally, it takes the number that's in front of the decimal point nearly every time. There is support to allow rounding within Python, although we'll be covering that near the end of this video. Integers are great within Python because they allow a lot of integration within loops and indexing and things of that matter. That's why integers are nice in Python. They also allow a clean output. If you make a lot of nasty calculations and you don't want decimals all over the place, you can assign them to integers, but do watch out for that because it might not always be the exact value it should be. So in that matter, you're better off still using the decimal number and using the round statement that I'll cover at the end of this video. Moving forward, decimals within Python are known as floats. They are of the float data type, like this. Let's put a decimal number in here, something like 0.67. This is a float. Now, you don't always have to put these float brackets around decimal numbers. Decimal numbers within Python as themselves are naturally floats. Python sees them as a float. Now, floats are supported in a way that they allow arithmetic processes just like integers do, but they do not allow indexing through a range of a float, for instance. So in our previous video with strings, we indexed through a string with integers. Obviously, with things like slicing, it was from a range from 1 to 3, or you could call on a single value, number 1 for that instance. With floats, you can't really index for a range of, let's say, 0 to 0.67. Python does not really understand that, and it just doesn't function. Why? If you want to know the back knowledge behind this, it's because there's a single element when you index at each point. So 0.67 would be in between 2 points. Now 0 would have a value and 1 would have a value, but Python doesn't hold any value in between them. So it might notice and know how to call on 0.67, but it will never ever find something there. So that's floats in Python. basically floats are decimal points in Python, integers are solid numbers. And the third one I'm going to cover is complex numbers. Now, this probably won't be used often by any regular user of Python, but if you want to do mathematics and data science with Python, Python does support complex numbers naturally. This is denoted by just writing the word complex and open and close brackets. Now, the complex number is attached to a J within Python. You might know it as an I, which strays from the usual way that Python does things. That mathematics does things. So we'll make just an ordinary complex number here. Let's go with 1 plus 2j. Now, this is how a complex number is represented within Python. So normally it's 2i, but Python sees it as j. Why this is because I'm not 100% sure, but I think I is commonly, it's used a lot for signifying an index, or when we go through loops, you'll see what I mean in a future video. But basically, if it was I there, it would cause confusion with that. So that's a theory of mine, might not be 100% true, but that's possibly why they go with a j instead of an I for complex numbers. So that's how a complex number is noted within Python. Once again, you don't have to put this complex and brackets around the complex number. Python knows that this is a complex number without those brackets. I'm just showing you those to see that's how you would turn something into a complex number if you wanted to. Now, moving forward, I'm going to cover if a number is assigned to a variable, how can we find out what type that number is easily? So let's just say we have the variable, for instance, and we have just the number 10 there. If we want to find out what type Python is interpreting this variable as at the moment, we can simply use the type method. And we put the variable name within the type method. And again, a print statement just so we can see it in the terminal down here. If we run this, it says it's of class int. So its type is an integer. You can do this with all of the other number data types we just covered as well. And I'll let you try that out for yourself. Now I want to cover just basic arithmetic on these numbers. So basic arithmetic, I mean your addition, your subtraction, your division, and a few extras, a floor division, and multiplication. Also to the power or indices or exponents, whatever you want to call it. Firstly, we'll look at addition. Now, just using a print statement again, so we can see it in the terminal, we can simply add two integers together like this. You can add two integers together, two floats together, an integer and a float together. You can basically do them with all number data types. So if we just run this, we get 20. So it does addition like you'd think it would. 10 plus 10 is 20, and that's exactly how Python interprets it. Now let's do subtraction. We're expecting a 0, and that's what we'll get. A 0 down here in the terminal. Now, just a quick example with multiplication. Multiplication is denoted by this little star. It's normally at your 8 key on your keyboard, if you have a standard keyboard. And this means multiplication within Python. And no, I'm not going to make the claim to all programming languages, but it's rarely the X within any programming language. It's always a weird symbol, but it's easy to find that out and roll with it onwards within your programming journey. So within Python, it's the little star near the 8 on your keyboard. For other programming languages, it might be different. It most likely is. But Python, it's this little star. So if you see this within any code base that you're working on, those two numbers near it are being multiplied. So if we run this, we should get 100. And we get 100 right here in the terminal. Now, the basics out the way, we'll cover the more funky ones within Python. So this is division. Still predominantly basic, but it's denoted by this slash on the keyboard, which is normally near the question mark on your keyboard and right next to the right shift. So if you're looking for it, that's where to find it. And you need to, actually no, it's fine. You can just click it. I don't think it needs a shift to be inputted. It's the main keyboard. So if we run this, we should get 1.0. See, Python puts the float there because it can be uneven. So say if we did 8 divided 10, 1.25. So it does recognize that, and it does support for that. Now, the next one is called floor division. So if we just run this, it's the exact same slash, but two of them, we get 1. So this gets exactly how many fit within the number. For example, we'll try with 8 again, and we get 1. We'll try with something larger, like 20, and we get 0. It's how many of the denominator can fit into the number on top that we are dividing into. So look at it as, let's go with 2. So how many times does 2 fit within 10? 5 times, and we'll get 5 in the terminal. We get 5 here. So that's how floor division works. Now, last one I want to cover is indices or exponents. This is denoted by 2 of these little stars. So if we do, 10 to the power of 2, we run this, we get 100. So that's how that works. Okay, moving forward, I just want to quickly cover rounding decimals to a desired amount of decimal points. This is done using a function known as round within Python. It's quite nice. It's literally just called round. So I'm just going to give an example of that now. So using the print statement again, just so we can see it in the terminal. And if we use round and we put a decimal number as the first number, and let's say to 1 decimal point, we run this, we get a 2.5. So it's rounded up correctly there to 2.5 from 2.47. And let's just jump a bunch of random numbers in here, and let's try round to a number with a few more decimal points. Let's go 3. If we run this, 2.473. So it's done that correctly, and it's rounded to 3 decimal points for us. We can even try 2, which is quite common with decimal points. 2.47, and 1 would be 2.5 again. So that's how rounding with decimal points or with floats within Python. Finally, with this basic number tutorial within Python, I want to cover random numbers. Now, this introduces us to our first importing of a package within Python. So we're going to cover that quickly now as well. So this is normally at the very top of your Python file is where you put imports. Now, a package is something that isn't natural to Python, but can be integrated if installed. Now, random within Python is quite naturally supported, but you still need to import it for use. But there isn't much installing. I don't think with current Python versions that needs to happen. if you just write the import statement at the top, it should work as intended. So it's import random. We literally just want to type import random at the top of our Python file. So now we can use this random package. So now to get a random number generated, or random integer for that matter, we can do something like this. So just a print statement so we can see the random number that we do generate. So you want to do random.randint, which means using the random function, which is accounted for in the first part here, and then randint is the method that the random function supports. So using random as the entire package, and using the randint ability or function from the random package. And randint just means random integer. So you want another close and open bracket here. So if we put in just a 1 here and a 1 there, we'll let you see what happens. So we get an output of 1. So it's generated 1 random integer, and it only had a range of 1. So that's why we only got 1. If we increase this number to 4, we should get a different number, 3. So we're getting 1 random integer between 1 and 3. Now if we change this to 10, and maybe this to 100, we can see how this kind of works. A 97. We've got a random integer between 10 and 100. So that's how it works. The first number here is the lowest number you want the random integer to generate, and the right number here is the highest. Okay guys, that's the end of the Python Basics video 2, covering numbers within Python and basic arithmetic within Python. Now, just another side note, there is a lot more to cover with numbers within Python, and they're quite powerful, and they can do a whole lot of things, and there's a lot of third-party packages that allow Python to do a lot of really complex math within Python, and it is used a lot in data science and in mathematics for that exact reason. And I will cover that in future videos, but it is definitely not at the beginner level, so I'm not gonna cause confusion by exposing you to any of those topics in this series of videos. If this was too simple for you, you might be ready for a higher stage in that. There's a lot of tutorials on YouTube that cover those types of things. I'm sure you can find one for yourself, but one day I will have videos covering those things as well. But this is a Python Basics video, so we're keeping it to the basics. So without further ado, I hope you enjoyed. Tap that like button for me. Really enjoy that. It helps out the algorithm. It really does. It's been Sxlly, and I hope I see you in the next one, where we'll be covering loops.